Third time's a charm, right? This is the third time I've tried filming this or recording this video. Both other times my computer completely froze and I had to shut it down. So, I guess we'll start from the top. Alright, so this is the final phase for the projections. Where you're going to focus on one of your case studies. So, in Mrs. Cantrell's class, you're going to have to write a paper about one of these case studies, one of the countries that you've chosen. If you haven't chosen a country yet, this is basically, you're going to need to do it now. So, a good way to maybe help make the decision would be to look at your correlation graphs of each case study. Maybe one of the case studies goes against your thesis or goes against, the global correlation. But all of mine basically mimic the global correlation in that they're positive and they're pretty strong. The one I'm interested in is Cuba. It's it's not a great correlation, but it's still okay. And it's all over the place, though, compared to where France and Sweden are very nice curves. So I think I'm going to focus on Cuba because I'm very curious about why, what might be causing their correlation to be so low. Okay, so you want to be starting on your case study population baseline sheet. We want to be on where you graphed your population over time. So that might be fertility, mortality, life expectancy, but we want to be on the case study sheet this time. Okay? And one thing I want to talk about quick is something Mr. Princeton and I have mentioned is about making sure your graphs, especially for the case study ones, have the same units. That way when you look at them to compare them, you get a good representation of the data. Right now, it actually, if you just look at these three graphs without paying attention to the units, it looks like Cuba could actually have a bigger population. And it looks like Sweden has the lowest population, and that's just glancing at these. So then when you look at the y-axis here, you can see, okay, Cuba's graph ends at 12 million people. And then when you look at France's, you can see that it ends at 70 million people. And then when you look at Sweden's, you can see it's 12 million people. So we can now tell, after looking at the units, that, okay, France's population is clearly a lot larger. But most people, when they're just glancing at these graphs, don't think to check the units. So we want to make them the same. So we're going to start on the x-axis and right-click, format axis, and then we want to change that to 1800, which is when our data started for population. And even though Cuba's didn't start till 1900, I actually want to leave it at 1800 because the other two graphs did mostly have data starting in 1800. You can see there's a little bit of lag for France, but Sweden's, which you can see from the table, starts right at 1800. And to keep it consistent, especially for these case studies, I want to have them all have the same units. So now we want to fix the y-axis. And like I said, France's population chart ends at 70 million people. So that's actually what we want to change Cuba and Sweden to, is 70 million. So right click, format axis, and we want to change the maximum to 70 million people. So I'm going to add 7 zeros after this. Okay. And now you can see, just glancing at these two graphs, clearly how big the gap is between France's and Cuba's population. Okay, again, changing Sweden's axis All right. And again, now these we can compare just by glancing at it. So you always want to make sure you change the smaller graphs to the bigger ones, because it wouldn't make sense to change France's graph to 12 million people, because then we would be cutting off, well, you actually wouldn't see anything. So you always want to change your smaller graphs to match the larger one. Okay, so now that we're done with that, we're going to focus on Cuba, which was the case study I decided to choose. And just like we did with the global global population graph, we're going to copy and paste. And I'm just going to go ahead and do this twice, because I'm going to do the linear and exponential predictions back to back this time. Okay, so first I'm going to go ahead and right-click on the graph there and add trend line. Linear for this one. We want to forecast 100 years and display equation R squared. Okay. I'm going to go ahead and make this so it's not negative. There we go. And then I'm going to, on this one, add an exponential trend line and forecast 100 years, display the equation in R squared value. And you can see with this one, it curves nicely and does not pass 0. So comparing these two projections right now, the linear R squared value is 0.87724, and the the exponential R squared value is 0.96868. So based on that, the exponential graph seems like it would be the better fit. And you could argue that the exponential graph is predicting by 2100, Cuba's population is going to be approximately 70 million people, which is where France is at right now. And the linear one is predicting 20 million people. And to me, just looking at it, it looks like the linear graph fits better, but based on the R squared value, I must be judging it wrong. So just keep those things in mind as you're going through this. Alright, so we're going to do the forecasting now. We need the years, because that's what we're going to put in for X. Our input on this graph here is years. So we want to input the years in for X, which will give us the population Y. Okay, so my data ended in 2013, so I'm going to start at 2014 and type the next 2 years, 2014 and 2015. Then highlight those two, click the right corner where the black cross appears, and start dragging out to 2100. Good. Whoops, okay. Then I'm just going to go ahead and copy holding my breath there, copy and paste the years. Okay. Now I want to do a linear population prediction. Alright, so looking at my equation, I have 1 capital E plus 0.8. So this is where I'm going to have to do the double click and change to scientific and go out to 15 decimal places. I think I've already said this before, but it's really important that you do this. I know the numbers get frustrating